Welcome to Peritos Solutions, your trusted cloud and ERP partner.
We talked about like migration modernization so far, and then initially Sid covered a bit about like traditional AI versus like generative AI. I just want to start with a case study here. This is like a cricketing app which we did in 2020 till 2022. This is like a classic example of like traditional AI and how things used to work. We actually spent almost like a year and a half on this to just to train the model correctly so that we can track the ball on the pitch. I'm just gonna play a video here so you can see how it used to work. This was a mobile app where a bowler in the nets can record a video. In the video, it can track the ball all the way on the pitch, draw the complete trajectory, calculate the speed of the ball, and then at the end, create a pitch map. And this was all done using like one single camera. Like the similar thing is also done like in cricket matches. They use 6 cameras to do this. So this was done using like using all the traditional AI kind of methodology, and then we use like all the AWS services so that we can process this in like near real time. So each ball used to take like about 60 seconds to process. So you can get like a speed of the ball within like 60 seconds on the mobile app. And it used to record like a video at like 240 FPS. So a lot of data used to go to AWS and then being processed near real time, get the results. And then collect all of that for a complete session. So so that we can create this kind of pitch map. So it was kind of like doing a 3D to 2D conversion as well of the pitch. So on this, you see the pitch as like in 3D is the depth, and then we used to like convert that into 2D. As I said, like the model training itself basically took like about a year and a half because we took about like 1,000 videos of bowlers like bowling in like different sets to see if we can identify the ball in the video, and then draw that kind of trajectory, calculate the speed. And then the initial problem with the deployment was it was really expensive. Like one bowling process, like one single video, used to take about $1 to process. We use like different techniques in AWS to able to like reduce that to 3 cents per video. And this was all done like serverless. When we launched the app, there were 20,000 users in first month. We processed 75,000 videos in the first month. And all of that, like the system was able to scale quickly. There were times when we were like processing 100 balls in 1 minute. So that basically shows like, you know, how the cloud strategy actually work and like how it can basically scale and support these kind of like scenarios. And like really good case study about like, you know, startups using some of the like cloud technology to really like go to market quickly. The co-founder of this was Loki Ferguson. He was working on this concept for 7 years before this to get this working. But then because like the technology was not that mature at that time, it took like that long. And then once, you know, cloud technology started like picking up more, like AI kind of mature more, this was kind of the result. Now going to the next side, which is the more kind of generative AI side. So how that evolved, and especially like on the AWS side as well. 2022 was year of like, you know, using AI mostly like in memory. A good example, large language model, like using large language model as is. So like ChatGPT, for example. So it works based on like the train model. So it already got like a train model set. You ask a question and it responds based on what it already knows. So there's a possibility that you can get like incorrect data, which is usually called hallucination, and it would never say like, you know, it is wrong. It will just respond like that confidently, like this is the answer. So if you know, you know, otherwise like you can actually, you know, mislead. 2023 was more like RAG, which is you know, using your knowledge base and apply large language model on that knowledge base. So like companies who want to use those large language model can have like their knowledge base so that the answer which they get is like more relevant to their knowledge or their data. So it doesn't come like, you know, from internet or like any information which is only available on internet. 2024 and 2025 is basically year of agents. So how you can combine like different RAG model to create like different AI agents which can work together to give the answer. Or it's not only like limited to just the chatbots. It's there are like way like different scenarios on how agents can work, or like how agentic AI is actually evolving. I'll cover some of the case studies of that as well. We'll show you how agentic AI can be used in like real world scenario. Going to the AWS services, there are a number of AWS services available for like using RAG to even like agents. And there are like there are different use cases to it. Anything from like using chatbot to like virtual assistants to have like a conversation analytics, which is Amazon Q. So you create like a complete dashboard on QuickSight. You can have Q to ask question about the dashboard which you are looking at, and it can explain you what's there on the dashboard. So if you are not into like data analytics as such, but you can still understand using that conversational AI. There could be like employee assistance. Code generation is like another one. It is start getting like more normalized now to have like the code generated through AI, and then personalization and productivity side. So I'll cover some of that as well in next few slides. So how we basically go through implementing the generative AI, and then said initially covered that part, like you start small. So you basically like pick a use case. So the Bailey's one I took like example I took initially. There was this one application which was migrated. There was like a very simple use case which came out, how to generate property description. They had like all of the data available. We can actually train the model on the data. We can use RAG real world to generate property description. It to an extent where different property manager write description in like different ways. It can understand like this is the property manager who's asking for generating the property description, so it will use their kind of language to create the property description. So very simple example, very simple use case as well. Just like and no chatbot in this case. Like it is basically like one single text field where they used to type the complete property description. Now it can be auto generated, and then they can look at it and then approve change it. So that's kind of like a usual life cycle. You pick a use case, you train the model based on your data, you check like whether it's working correctly, and then optimize. One of the applications which we built is, and this is something which we use internally as well, is for like helping recruiters. So a lot of time, basically, recruiters they need like the complete like job description to find people, and they get stuck because people who are responsible to give job description, they are busy. They're not able to give like complete job description, or they created something, they got something from LinkedIn which is not matching exactly like what we're looking for. So we kind of like use our own like set of like job descriptions which we had in past, train the model using that, so that the recruiter can first generate the job description using the keyword which we provide. They get like the resumes which they can feed into the system to validate like if it's matching to the job description or not. So it gives a complete summary of the resume which they can understand, and then also give like a what things are matching and what's not matching. The next version of it basically gives them a sample set of questions as well, which they can ask as a like a initial filtering round. So they can ask some set of questions based on all of this. It also generate like a sample answer for that, so they can match like if the candidate is able to answer those questions or not. So it helps like complete recruitment process. So you can have like one prelim round done from the recruiter itself, and they can use this complete model. We can have like all the data available within the system. Now, the other thing which I was talking about, like using agents, or like how this is basically evolving. So if you go back to RAG, it is still like you ask a question and it gives a response. So there's still like one model, one prompt, and one response. This can be changed to multiple models, multiple responses, and there's an orchestration between that. So you can have like different agents created based on the data. Each agent can be created based on the system prompts. So you can define like different characteristics of agents. Once the user asks for input, it will create like it will give the same question, or it can give like the initial question to one agent, which can give an answer, which can be input to another agent, which can work on that answer, give to another agent. Now these agents can be LLM-based agents or RAG-based agents, or it can be just tools. So it can basically call like another like third-party system to get some additional data based on the answer of first agent. And then there's like a complete like another like AI agent which is running, which is just doing the orchestration. So it knows like which different agents to pick to get the correct answer and then do the response. Once we do something like this, it basically reduces hallucination by a lot, because your answer is now validated. So it's not coming from just one RAG model. So accuracy and the performance improves quite a bit. Now, how these agents are like more kind of interesting. So in AWS, I'll just show the next slide. In AWS, when you create the agents, so it's available in Bedrock. There's an option to create like agent. An agent is basically, once you have the data or knowledge base available, you give like a system prompt for the agent, or you create like a tool for the agent. So these are like all triggered through lambdas. And then you can actually see like how those agents actually created the response, and then the third agent actually combined the response from two agents and then gave the answer. You can see the complete like conversation, and this is like conversation which is happening between the AI models. So uh, that's basically how it can improvise on the responses and the quality of response. So this is basically like using the AWS like Nova model. So Nova is like the latest version in Bedrock, and there are like different variations of it as well. So depending upon your use case, you can pick like which version is more suitable. You can combine like those different versions as well to get the answer, or like make it like more relevant to your use case. Now the case study I was talking about, this is like Agent Analytics is like a SaaS-based AI company. We're working with them for almost like a year now. We are migrating them to AWS. They basically started on-prem, like they did like initial their model training and the initial prototype on-prem. What they have created is basically like a simplified version of agentic AI. And how it basically works. This is basically a comparison between a chatbot which is running on L'Oreal and a chatbot which they implemented for like another similar company in India. So usually now when there's a chatbot, people who are like more used to ChatGPT, they don't write like a search query. They write a normal question, right? So that's like a difference which has happened like in the last few years, where you don't use chatbot as Google. So in this case, they basically the user actually asked for their problem. It responded based on the knowledge base of the company about like different products, and also recommended the product. These are different models, different agents are running. They asked similar question on L'Oreal side, and the role from the answer, it seems like L'Oreal is actually using just LLM, not RAG. So they got like a very like generic response, and it is not very friendly. Like you don't get like anything out of it. So there's a comparison between like multiple examples, similar questions asked on both the sides. One is using agentic AI, another most probably not. Underneath it is basically the way it works is like in the customer side, they have created multiple agents, which are basically based on one agent which is specific to like recommending products, another agent or another set of agents which are related to like finding the correct information from that product description to give the answer to the customer. And then use that and under the chatbot. This is still using like Bedrock for like all the models. They just created like a different like agentic framework on top of it. So you can bring like your data, store that into S3 bucket. Then you can use like different models which are available within Bedrock, and then create these agents. Now, how it works. This is the kind of like the UI to basically create those agents. And there's a similar UI available within Bedrock as well. So you give, in this case, they give like a system prompt to generate the agents. Based on the prompt, it will suggest like multiple agents. And then you can create a workflow of agents. So one of the use cases I was talking about, like, just, you give a response, you get, you give a request, you get a response, like a very linear option, right? So, but the agentic AI is you don't really need a response on the chatbot. You might want to invoke another system to do something. And that's possible through the agentic AI. So in this case, they created like those multiple agents. Now they gave the context, which is like those 3 files. And then they ask question based on those files. So it's still using RAG. It's just a more kind of like dynamic RAG. So you don't have like a knowledge base already available. You just upload that knowledge base to get the answer. And this system is also running completely serverless. If there are like no requests, it doesn't charge them anything. The another one which I was talking about, like using Q in QuickSight. This is one of the dashboard, another cricket-based app which we're working on. This is actually data from like different New Zealand cricketers at the moment. Loki Ferguson, he looked at this dashboard and like initially when we created the dashboard, he couldn't understand anything. Like what all these things are talking about, like why all these graphs. So we added Amazon Q so that he can ask question about like those different charts and get the answer so he can understand all of the data from different layers.
Thank you for watching. Get in touch if you're keen to discuss more.